homework's going to be. Math 152, all the homework assignments, all the quizzes, all the tests, all the final exam, all the good stuff that gets you points are on WebAssign. It's a company called Cengage that produce it. There are information on Canvas about how to log in and how to do it. Our class key, as it's called, is Olympic 42852728. So that's Olympic 42852728. That information is, as I said, on some of the emails I've sent you. It's also on Canvas. You get 2 weeks grace period. So if your financial aid is not through, and I can understand based on the horrendous stories I was told about the summer financial aid being it wasn't our guy's fault. Honestly, it wasn't. CTC has just been a pain in the butt for financial aid. I've been told it's much better, but you might not have your financial aid yet. You've got 2 weeks free, right? So you go in, you check in, you log in, whatever, right? Start doing your homework. Don't you pay, end of 2 weeks, they'll come up and say, look, you better pay now if you want to keep going. And hopefully by then you'll have your money and you can pay. You can pay online in the Cengage. I think you just need your credit card and you're good to go. You can also get a code from the bookstore. And that takes a bit longer because they have to post it to you. But if you have to do it that way, then feel free. There are other resources if financially things are tough for you. SING, S-I-N-G, Students in Need Group. That is in, I'm pretty sure I put it in my syllabus or somewhere. I definitely put it in Canvas. You can contact them and they will try and, if they're able to, they will try and get you some resources. Maybe they'll be able to help you with your, to pay for WebAssign, or maybe they can give you some other help, you know. If you don't have some technology, and I can't see half your faces, so that either means you don't have a webcam, but you should, you can contact Help Desk and the college and do that. You could contact SING and, you know, get a webcam. What else could you do? You could use your CARES grant money, and I mean, they're not expensive. What can you get a webcam now for $50? Probably. Right. So that would be something you need to do. The other side of the coin after WebAssign is Canvas, and on Canvas I have all the Zoom lessons, including this one, will be in Canvas. So when you want to say, yeah, I remember I'm doing this, but I've forgotten and I'd like to see that lesson again, or I missed it for some reason, you can go and do it. It'll be about a day late, but it will be online. I also have some videos of other people online that I found useful. So if you want to see other ways of doing it or other examples, you can do that. I have PDFs, I have PowerPoints, and we have tons of stuff there. So use Canvas as a resource. And I think that's all the stuff. Oh no, one more. The organisation of this class is going to now be slightly different from what you may have got from me before. It's going to be in 2 week chunks. So we're going to do 2 weeks. And at the end of that 2 weeks, all homework assignments have to be done by Tuesday, October the 4th, I think. Not Tuesday, by Sunday, October the 4th. So don't wait until Friday, October the 3rd and think you're going to do 2 weeks worth of homework assignments. It ain't going to end well. So, you know, be proactive, do your homework as soon as you can, keep doing it, you know, as we go through class. Oh, I now know how to do this, I'll do that homework assignment. I now know how to do that, I'll do the second homework assignment. At the end of that 2 weeks, on the Sunday at midnight, that's when the homework's due, all homework for those sections will close. That's it. You won't be able to do them anymore. When you go to WebAssign, the only assignments you will see are the ones that are due for this 2 week period. So if you can see it, you have to do it, right? That's basically how it's going to work. Now you have to do it in 2 weeks, but do it before. The Monday after that, so I guess that would be October the 5th, instead of a class lesson, we'll do test 1. And test 1 will be in all the things that we did in the first 2 weeks. And then 2 more weeks of stuff, a test. 2 more weeks of stuff, a test. You can see how it's going to go 2 weeks to weeks until the quarter's finished. And that's, the last one is technically 3 weeks, but most of that is taken up by Thanksgiving holiday. So physically, it's like 2 weeks worth of days over a 3-week period, right? But, you'll see that. It's in the syllabus. I've told you what sections are going to be covered. So you'll know exactly what's going to be covered at any given 2-week period. Your tests are worth 20% of your grade. Your final exam is cumulative on everything, and that's worth 30%. And then you've got your assignments and participation. And your assignments are going to be WebAssign, just a homework. That's what I mean by assignments. And I believe they're 30% of your grade. And then class participation, which is what you're doing right now, is 20% of your grade. So for being physically here and taking part, you're going to get a fair amount. So that is important that you turn up to class and don't miss any days. And the way I'm going to do attendance is sometime before the end of today, I'm going to ask you to go to the chat section and just say hi. And then I save the chat, and then I can just go through and say, Kathy was here, check. Katsumi was here, check, right, and do like a class attendance that way. Don't do it right now because I'm not going to look at it right now. I'm going to specifically pick a time and say you've got 1 minute to do it. And if you don't do it in that minute, then it means that you didn't have your video on and you were watching TV, in which case you weren't here to do it, in which case you don't get attendance. So if you're wondering why I'm doing it that way, I will tell you kind of out of the blue, hey guys, do it now, right? And I'll give you a minute to hit the chat. You just need to say happy face or hi or something, just whatever it is. Any questions before we get started on our lesson now? We good? Right, and remember the old adage, it's in the syllabus. So it probably is in the syllabus. Okay, well, let's look at big picture. Let's look at Calculus 1. If someone said to you, what was Calculus 1 or how did it start? I'm pretty sure that unless you were taught by someone who doesn't do it in the traditional way, didn't Calculus 1 start from what was called the tangent line problem? Remember that? That's actually historically how derivatives were created. And just to remind you what the tangent line problem was, is that you have a curve and there's some point in the curve, we'll call it P, and the tangent line is this red line, and we'd like to know the exact value of the slope of that tangent line. And we began by doing it numerical estimates. Now, the way the numerical estimate would work is that you choose 2 points, say that point there and this point here, and you find the slope between those 2 points, and that blue line that I just drew, that slope would be an estimate of the slope of the tangent line. Now, it's not that great right now, but can you imagine if you choose 2 points really, really close to P, don't you get a really good estimate to the slope of the tangent line? And then from there, we moved on to introducing the idea of limits. You know, the limit as x tends to 2, the limit as h tends to 0. And the reason we did that is so that we could then look at, well, what happens if you take those 2 points and essentially bring them together? And the way that you imagine that is by a limit as, say, h tends to 0. And that allowed us to eventually get not just the slope of the tangent line at any given point, but didn't that give us this fella? which is called the derivative function. And what that function would allow us to do would be to find the slope of the tangent line to this curve at any given point by just finding this function called the derivative and plugging in the x coordinate of the guy you wanted. And then from that point onwards, wasn't Calc 1, how do you find derivatives and then what can you do with them? So the kind of things would be power rule, product rule, quotient rule, chain rule, implicit differentiation, logarithmic differentiation, all sorts of ways of how do you differentiate this function. And then the uses would be things like, couldn't you use derivatives to find where the top and bottom of hills were, right, max and mins? Couldn't you also use it in kind of physics situations? If the original function was the position function, s of t, then wouldn't its derivative be the velocity function and its second derivative would be the acceleration function? That's one of its uses. And there are other things that you could do, optimization questions and so on. So relative rates there, my brain's chucking in some ideas. So that was Calc 1. It started off by finding the slope of a tangent line, and then it progressed to derivatives, and then how to find derivatives and what can you do with them. So what's Calc 2 going to look like? Well, Calculus 2 also started with a problem. Only in Calculus 2, the problem wasn't anything to do with slopes of tangent lines. The problem was how to find the area under a curve. And that's kind of where we're going to start. We're going to look at how do I find that shaded area? So it's the area below the curve but above the x-axis. That's what we mean when we talk about area under a curve. That shaded, cross-hatched guy. How do you find an area? Now, eventually we want to find the exact area, just like we wanted to find the exact slope of the tangent line. But as a kind of preliminary to that, maybe we could find numerical methods to estimate that area, right? Just to get something that's close to it. And in the same way, you know, remember you pick 2 points either side and use them, right? So how do we tackle that problem? Oops, I can't draw straight lines, but that's fine. Well, give me a few seconds to, oops, get this fella set up again, or at least try to. Right, there's the same curve again. We're starting at x equals a, maybe at x equals 1, finishing at x equals b, maybe x equals 20, right? So I want to know the area from 1 to 20, from 2 to 5, from whatever it is. So let's imagine how you might generate an estimate. Well, you probably want to simplify the problem, you know, something that's easy to calculate the area of. Would you agree rectangles are pretty easy to calculate rectangles for? So what we'll do is we'll split that shape into lots of little rectangular strips. And to make life consistent, we'll make the widths of the strip the same, right? We'll make them all the same width. So 1, 2, 3, 4, 5. There, that's 5 strips. So in the jargon of this, n equals 5 is how we would tell people that I was going to do 5 strips. Now, each of these strips, there's 5 of them, obviously. None of them are rectangles. You know, see if you focus on that first strip, isn't it curved at the top? I can't really do curves. I can do rectangles. So I'm going to, kind of arbitrarily, I'm going to choose to use the height of the curve at the right-hand side to generate my rectangle. Can you see? That would give me a rectangle. Would you also agree it's a little bit smaller than the real area, but it's close. Now, if I move to the second one, do you see I could use that side or I could use this side? For consistency, I'm now going to use every single time the right-hand side. Now, if I found the area of all 5 of these rectangles and I then added them up, would you agree that it would be an estimate for the real answer? Would it be exact? It would be an estimate. Based on my very badly drawn picture, I think it would be reasonable to assume that it's an overestimate. In other words, it's bigger than this. Agreed? Now, I decided to use the right-hand side, right? I had a choice. I could have used the left or the right to get the height of the triangle. Since I used the right, we call this guy R5. And I'm making this up. Can we pretend that it was 17 square units, right? I added all the rectangles and it was 17. Wasn't there another choice here? Couldn't I have chosen not to use the right-hand side, but the left-hand side? For instance, see this rectangle here? Wouldn't the triangle be this fella? Or the rectangle it should be. It would be that fella. And see in the second one, wouldn't it be this guy? And if I did the third one, can you see it would be this guy? If I did the fourth one, do you see it would be this guy? And if I did the last one, it would be this guy. And that guy, because I'm using the left-hand point to get the height, it's not a surprise they call that guy L5. And can we pretend that it was 15? So do you see there are 2 distinctly, slightly different choices here in which rectangle heights to use to generate the area? Either I use all the right-hand sides of my rectangle to get the height, or I use all the left-hand sides of my rectangle to get the height. Would you agree that this one here is an underestimate? So it would be reasonable to assume then that my answer is somewhere between 17 and 15. So even although I do not know the right answer, even although that is true, I don't know the exact answer. With a little bit of common sense, would it be reasonable to say that the true answer is between 15 and 17? At least I know that much. What's about the only thing I can do if I want a more accurate estimate?
Make smaller strips.
Right, or make more strips, which is what you're saying, right?
Yeah.
Maybe do 50 strips. Would you agree if I did 50 strips, I'd probably get a more accurate answer because the error at the top would be tiny. And although there's 50 of them, it still would be tinier, right? And so in general, if you want to do a numerical trick or a numerical technique to estimate, the more strips, the better, right? It's not always the case that one of these 2 is overestimate and one of these is an underestimate. Can you imagine a curve that goes up and down like a wavy line kind of thing? In those situations, it might be quite difficult to tell if the left or the right is an over or an underestimate. Can you imagine both of them could be overestimates? You know, if you draw a curve a certain way, you know, and you do strips a certain width, both could be underestimates, whatever. One could be an underestimate and the other be a slightly better underestimate, you know, those kind of things, right? So that's just a one particular situation. Don't think of that as being a truism, right? That the left and right are always over and under. It depends on the shape. Simple shapes are ones that are always increasing or ones that are always decreasing, right? If that's the case, the function's pretty much going uphill all the time or going downhill all the time, right? Then this will be true. One of them will be an over and the other will be an under. Now, at this point, we're going to stop working on this problem totally. And we're going to look at something that we need to be able to use, which is going to return to help us later on with this guy. I could do this question with 5 strips probably relatively quickly. If I said to you 50 strips, are you beginning to think, nah, I don't want to do 50 strips? Can you imagine how many separate calculations you would need to do 50 strips, right? Do you want to do 5,000 strips? No. I'm probably never going to do 50, knowing how lazy I am, but I'm never doing 5,000 unless you pay me a lot of money, right? But we don't need to. If you're into computer programming, you know it wouldn't be too difficult to create a program that would do this for you. And in fact, your TI-84 calculator can do areas under curves. And I'm pretty sure it basically has a little program that does this, but it does it like, I make up a number, with 5,000 strips. So it's really accurate. So what's the new guy in town? Well, the new guy in town that we need to change tack is called sigma notation. What this is going to do eventually is help us with this problem, because it's going to allow us to use the calculator to get these guys when the strips are onerous big, or to be honest, if you just fed up doing button pressing, you can do it really quickly by using sigma notation. So let's show you what sigma notation looks like. That is an example of sigma notation. It's basically a nice, concise mathematical way of writing down a whole load of things being added. So, how does it work? K is called the counting variable. In this case, K starts at 1, and then you finish at 5. And what do you do with K? You add up all the K cubes. So it would be 1 cubed, plus 2 cubed, plus 3 cubed, plus 4 cubed, and finally, plus 5 cubed. Okay, now, that's 1, that's 8, that's 27, that's 256, and that's 625, and you should be amazed that I can do that in my head, because I'm amazed I did it in my head as well. So here it goes, 1 plus 8 plus 27 plus 256, and finally 625, and the answer is 917. So sigma notation is just a convenience of, instead of having to write this down, you can write it like that. Now you might think, it's not worth it. Well, here's another sigma notation where it really is worth it. Let's do n equals 1 to 500, and let's do n squared plus n. Have you noticed that in sigma notation, the counting variable can be any letter of the alphabet you like? K and N are the most common letters that you'll see sigma notation being used. I have seen M used occasionally, but very rarely. Now, what would that look like? Well, it'd be 1 squared plus 1, add 2 squared plus 2, and no, I am not going to do any others, plus dot, 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 plus 500 squared plus 500. Wouldn't it be nice if we could get a calculator to do this? I could do that kind of by hand. Nah, not doing this by hand. So this is what sigma notation. Are you comfortable with what sigma notation looks like? How the structure of it lends itself to this calculation? Does that make sense? How this bit goes here and you start with 1 and you finish with whatever you finish with. It doesn't need to start with 1. Couldn't you start with 0 or 22 if you felt like it? Couldn't you stop with any number? It makes sense. Don't you have to have whole numbers? You can't stop at 1.2. It has no meaning, right? Any questions so far? I'm going to give you a few seconds to grab your TI-84 if you've got one. If you don't have one, you really do need one for this coming 2 weeks because you're going to be using it a lot. I have a link in Canvas to a TI-84 emulator. So if you don't physically have one, it's hit and miss. It works in my computer. Students have told me it doesn't work in theirs. As I say, it's a hit and miss. As I say, it works for mine and I'm happy because of that. Hopefully you've got the guy by now, right? So you've got, those who've got one have got one handy. I'm going to set up a few things. Shouldn't take more than a few moments. Oh, darn it in space. Okay, we're good. Right, that last one we did, I'm going to do a version of that. And here we are. Right, you should be looking at a TI-84 emulator. That's the one I was talking about. And you should also be looking at a PDF. Well, it will be a PDF, which I will put on Canvas that takes you through the steps of how to do this particular calculation. So the one I've got here is n equals 1 to 100, n squared plus 1, right? Very similar to the one we had a few moments ago. Right, so how do you do it? Well, first things, you need to set up your calculator to be in sequence mode. So you hit mode and you go down here and you go across to sequence and you hit enter. Got that? Okay, now get out of that. That's basically step one. I'll jump to the end here and show you what you've got. Oh, darn it. Note to self, I'll put down here that basically you do the sum of a sequence, right? And that's what it's going to look like. So you're going to go blue button, start. That'll get you into the list. So second list. You're going to go over to the maths option and choose number 5, sum. So we're going to do the sum of a sequence. That's the way the calculator does sigma, right? It's the sum of a sequence. So we've got sum. I'm now going to go second list, and then I go to calc, and it's also choice 5. Not that one, you're not. Let's do that again. What on earth did I hit? I've got a video of this anyway, so if I screw up, I don't know what I hit there. I'm sure I hit the right thing, but who knows? Yeah, I don't know what I hit the first time. Right, sum of sequence. Then you type in this guy. So when you hit the X button, it's now n. So that's n squared plus n, comma, n. I know that's silly, but you tell it what the variable is. It was pretty obvious it is n, comma, start at 1, comma, finish at 100. And then close with a couple of brackets. So sum, sequence, whatever the guy is, comma n, comma 1, comma 100. Now, the only thing that's really going to change is that this fella here, the n squared plus n, is going to be n cubed, the sine of n plus 1 over n squared, right? It's going to be something, right? It's going to be a formula with n in it. And you'll probably start at 1 or 0 most of the time. And 100 might be 100 strips. Can you imagine you're doing 100 strips and that N was your formula, right? 100 strips. Now, when I hit enter, I better get the answer. There you go. 343,400. You like? A calculator way of adding up a heck of a lot of things. Right? So I'm going to go out and back in again. I'm going to give you a Sigma 1 to try out on your own if you've got a TI-84 or equivalent, to try it on your own, and then I'll do it after you. So we are going to do Sigma N equals 1 to 50, and you're going to do N cubed plus 2N. Okay, you got 1 minute. If you know what you're doing, it should only take you a minute to do it. So Sigma N equals 1 to 50 of N cubed plus 2N. Okay, let's try it out. We'll see if it worked for you. And if you didn't have your calculator, I guess you're just going to watch a second version. So, excuse me. So, second list, math choice 5. That gets you the sum. Oh, hit too many enters. There we go. Going too fast for my own good. Choice 5. Second list, choice 5. The formula was N cubed plus 2N. So there's N cubed.
I think it's wrong because it says sum of sum.
Oh, darn it. Did you all catch that deliberate mistake? I don't know where my brain is today. I think I'm trying to do too quickly because we only have a few minutes and I want to get this over with. There. I think I've done some sequence. Now I've done it right. So it's going to be N cubed plus 2N. So there's my N cubed. And here's my 2N. And then comma, the N, comma the 1, comma the 50. And then enter. Now, that it might be difficult to understand how that thing is going to help you with the area using those little strips. But can you imagine that the N cubed plus 2N is a formula for one of those strips? Then if you do 500 of them, aren't you do basically 500 of those strips all being added together? And that's pretty much the technique, isn't it? So you can be really accurate, numerically estimate, by just having lots of strips. And this sigma notation is essentially going to be our friend. I believe, for the most part, your homework the numbers that you're asked to use, or the number of strips that you get asked to use, are not huge. So you could probably do it without the Sigma notation TI-84 shortcut. But if you do it that way, it's going to take you at least twice or 3 times as long. And there are more chances to make mistakes in that situation. Because in the thing we just did, apart from sum, right, that's a pretty dumb mistake, right? It ain't that, if you know what you're typing in, it ain't that difficult to get it right. Right, so that's why I'm kind of selling this. So what I'm now going to do, if I can get out, it's this guy here. Yeah, stop. Right, we got 3 minutes and I want to use all my time, but right now, the first minute of it is go into chat and say, hi, I'm here, or whatever you want. And while you're doing that, I'll get set up for what we'll do for the other 2 minutes. Okay, that's attendance. Time up. You all got your hi in? Right, let's move on now to our last thing for today, and that is WebAssign. I hope you are looking at least the way my WebAssign looks. Is that what you're saying? Right. Now, when you go into WebAssign, do you see these guys here? These represent your 2 weeks work. So you got to get all this stuff done by 2 weeks. That guy at the top is, it should take you about half an hour or less, at least from the students that have done it. It's pretty quick. It's just getting you used to WebAssign if you're not already familiar with it. So here is the one that we're doing. So I'm going to click on the view version of this. And it should kick in. Right, I don't know. Can you see the homework screen, or will I have to go out and in? Okay, it's out and in again. This one. You're looking at it now. Right, so this is what your first homework is going to be. Do you see it starts off with sigmas? Can you imagine that you could do this fella? Well, actually, I should hide the answers because that's a distraction. You don't get the answers either. Forget it. Right, I should have done it earlier. Right, but basically you type in answers into boxes. So you type in 13 here and you type in k squared. So if you hit k, you then go over to the right-hand side and there's buttons here for various things. That would be for the thing, and then you do k squared. And that would be, you're right. And if you're wrong, it will tell you you're wrong, and you get 3 shots. So that's how your homework works. Now, if we scroll a little bit further, can you see that they're doing, and this probably, well, this will be tomorrow's kind of stuff. Can you see they're beginning to do the 3-strip or 4-strip technique, and they give you a whole load of stuff, and they ask you to just basically, they're kind of talking you through the process of estimating. And here's one where you have a little video, same basic idea. And then we have some little sigmas here. But can you see how this one, you have to do sigma, and the right answer will be 511 when you do it correctly. So that's pretty much what your homework is going to be involved. It's going to be combinations of sigmas and finding areas of rectangular strips to estimate the area under a curve. So that is about it. So when I come tomorrow, or when we see you tomorrow, we'll spend time looking a little bit again on the sigma notation just to get you familiar with it. And then we'll focus on estimates of areas under curves using strips. And we'll show you how you would set it up and then how you could convert that into a sigma notation that you can then use your calculator to do the answer. And it cuts out all that middlemen of, you know, this times this plus this times this and doing it 10 times and getting really bored. Any questions before we go? Are we good then? We should finish with the joke then, shouldn't we? Are you ready?
Send it.
Send it, okay. That sounds a bit hesitant, Andrew, but here goes. Do you know I've cut down 500 trees in my career? I know that for sure because I kept a log.
I hate it.
Oh, you hate that one? Oh God, you're going to have a really bad 11 weeks, Andrew. You're going to have a really rough 11 weeks because that's one of my better jokes. Okay, guys, I've made you suffer enough. We'll see you tomorrow. And look, CARES grant, right? Apply right away. And
Already done. You're gonna get that 10%.
And I want that 10%. Unmarked bills, send them to me through the mail. And what else? And if you don't have a TI-84, try out my link to, I think it's called Wabbit EMU. Let me check it in case you want to just look on your own. Yeah, it's called Wabbit, W-A-B-B-I-T-M-U. And that'll be the guy that I was using. That's the guy who I'll actually be using, that software, when we do examples of using the TI-84. I find it's much more realistic than the TI-84 emulator that TI-84 gave me. So you can use that online, or you can physically get your calculator. It's kind of more convenient for me anyway if I've got a physical calculator. I don't know why, but it just feels better. But at least it's an option. Okay, bye-bye, guys. I'll see you tomorrow.
Bye.
Oh, and it's time.
Okay, bye-bye, Rory. You're the last one, unless you have a question. Nope, you're out of here.